Well, it's a pleasure to be back here on the campus. I was here 3 weeks ago and had the opportunity to share ideas with the Google staff, which was stimulating, about my new book. And I'd like to share with you ideas I have that I've been developing over 30 years on 3 important trends. The exponential growth of information technology, which is not just computers, it's not just telecommunications. The second major trend is that information technology is increasingly pervasive, affecting everything we're doing. We're understanding our biology as information processes and gaining the tools to reprogram them. I mean, how much software do you use that you haven't changed in 30 months, let alone 30,000 years? And that's about the amount of time in which we haven't changed our genetic information. And there's some genes we'd like to turn off. I'll come back to that. And the third is the increasing decentralization of our technology base, of our infrastructure, which is really being facilitated by this exponential growth of the power, price, performance, bandwidth of information technology. The long tail is a good example of that. We've democratized the means of creativity. A college student in her dorm can command the equivalent of a $1 million studio of 20 years ago. The same for making movies. A blogger with a PC can reach millions of people. We will ultimately actually democratize the means of production once we get to full-scale, tabletop molecular nanoassembly, which I believe we'll see within about 20 years. So we'll be able to actually fabricate just about anything we need from inexpensive information resources. So let me take you quickly through this, and I think this is a good audience to try to compress this into 20 minutes. But things have been accelerating. This actually goes back to biological evolution. But in technology, it took half a century for the first virtual reality technology, the telephone, where you could actually be with someone else, despite being hundreds of miles apart. That never happened before a century ago, but that took half a century to be adopted by a mass audience, by a quarter of the US population. Recent technologies like the PC, cell phones, the web were adopted in about 8 years' time. I mean, blogs, it's like 2 or 3 years. And if you look at different information technologies, telephone, radio, television, took decades to be adopted. These recent technologies are measured more in a few years' time. And I don't want to dwell on this slide, but there's been a basic acceleration. These are powers of 10 on the x-axis to how long ago this paradigm shift took place, and on the y-axis, how long it took to implement that paradigm shift. So the first paradigm shift, which was actually creating an information backbone to evolution itself, to biology, DNA, actually RNA came first, took billions of years. But evolution works through indirection. It creates a capability and then uses that capability to bring on the next stage. That's why an evolutionary process accelerates. And we can simulate evolution in the computer with genetic algorithms, something I've done in the field of pattern recognition for several decades. And we see the same type of acceleration. So the Cambrian explosion, where all the body plans were evolved, went 100 times faster. Only took about 10 million years. And biological evolution kept accelerating. Homo sapiens evolved in a few 100,000 years. Only actually 3 minor genetic changes involving a few tens of thousands of bytes of information distinguish us from our as yet unidentified primate ancestor. A larger skull at the expense of a weaker jaw, so don't get into a biting competition with another primate. More of our brain is devoted to the cerebral cortex, and we have an opposable appendage that works. Chimpanzee, the pivot point is down by an inch, so they don't have a power grip, they don't have fine motor coordination. We can actually manipulate the environment, and that brought on the next evolutionary process, which was technology. The first stages were a little bit faster, stone tools, fire, the wheel, were tens of thousands of years, and then we always used the latest generation to create the next. So half a century ago, the first computers were designed pen on paper, and now we, of course, use computers, and computer-assisted design software will work out 10 different layers of intermediate design.